Okay. So just as a reminder, I'm going to be grading our work, the homework, potentially that night, that Wednesday night during the final exam. And so if you have any sort of missing homework assignments that you want to go back and do, remember you do get half credit for those if they're late. But that's still a good way to review, as well as earning a little bit of extra points, right? So I would encourage you to do that. We have a week here. Well, so our work from section 7 is due on Friday. Normally it's Thursday, but I pushed it to Friday just because we don't have anything new between them and the final exam. There's one review assignment on my math lab, and that's also due as a homework assignment. So you should do that, as well as work on your note sheet and looking over the practice exams. But it's also an opportunity to catch up on maybe some other things that you might have missed. I would again focus on the newer material. So the last 3 sections are going to be much better represented on the final than the other sections. So that's what you would want to start with. If you do end up doing a bunch of missing homework, you should let me know. I don't automatically go back and rescore all of the homework unless someone tells me they went back and did some extra work. So I'm happy to do that, but you just have to let me know if that's the case. So, and that's, again, that's a really good way to review. I think that review assignment is also helpful. And then just kind of doing some of the problems like you would on the practice tests. And if you run into some formulas that you need, then you can put those on your note sheet, right? And work through that as a process to help you, be well prepared. You've all put in a lot of work over the semester, and we want to make sure we kind of maximize our results by doing some work to study for the final. It may not be in the cards to study 5 hours every day, right? That might not be possible for you. But a little bit of studying does go a long way, right? So spending a couple hours is where you're going to get the majority of the benefit, right? More time is better, it's true, but the benefit starts to get smaller and smaller as you spend more and more time, right? So it varies for different people, but a couple hours is a good start, right? To make sure you get close to your kind of maximum, right? Like what you should be getting. So that's kind of the layout here, or the focus for the next week. Do you guys have any questions from the homework problems at all?
I do.
Great.
I was stuck on one problem where it says sketch the graph of the quadratic functions and x of symmetry. And then it says state the vertex and give the equations of the x of symmetry. So it says h parenthesis x parenthesis close equals x squared plus 5.
X squared plus 5. Okay. Let's take a look.
And I think I might have sent you a message on.
Say it again.
I said I think I may have sent you a message on my lab.
Okay. Yeah, I'm not sure if I got that, if it was recent or but let's see it. But anyway, let's take care of it now. So the last 2 homeworks in chapter or section 7 are focused on graphing quadratics, right? So we know a quadratic looks like ax squared plus bx plus c, but here we're looking at quadratic functions. So we're thinking of the y value as being equal to this quadratic relationship with x. And there's lots of different versions of these, but just like a line comes from a linear equation, a quadratic equation is always going to generate what's called a parabola. And parabolas, again, can have lots of different forms. They can open up, they can open down, they can be very skinny, and they can be very wide. So these are all potentially parabolas. It should be a little more curved there. So our goal in this section is to be able to take a quadratic equation and turn it into this sketch of a parabola. One thing you can notice about all these parabolas is that they all have this point where the function kind of changes direction, and that's called the vertex. And usually with a parabola, we just kind of call the vertex HK, like H is representing the X and K is representing the Y for that vertex. So it's a point, and that's a really important point on any parabola. So we want to be able to find where that is. You also mentioned this axis of symmetry, and I will tell you that the book really loves the axis of symmetry. I'm a little bit lukewarm on it. You won't see it show up on the final exam, but it certainly shows up on the homework, and it's not hard to do, so it's worth figuring out. The axis of symmetry for all of these, you'll notice, is where it splits the parabola directly in half, and that line is always vertical, and it always falls right through the middle of the parabola, right through the vertex. So a vertical line that goes through the vertex is always going to look like x equals h. So that is my axis of symmetry. And when you're graphing these on my math lab, you need to draw in this dashed line for the axis of symmetry. I always get a lot of questions from students who are like, I know I did this right, but it's marking me wrong. And half the time it's because they just forgot to put that axis of symmetry through the middle of their parabola as a dashed line. So that's what it's often looking for when it's asking you to graph, and you got to remember to put that in there if it asks you for that. So the question now is, okay, this is kind of a general overview of what quadratics look like. How do we find it for a specific quadratic? And a good starting point is to remember that we do know what f of x equals x squared looks like. That's a parabola whose vertex is right at the origin. And it has lots of points here, but there's a very convenient kind of secondary point, which is at 1, 1. There's also, because it's symmetric, there's a point over here at -1, 1, 2. But it turns out this vertex and this other point are really useful for keeping track of different parabolas. So this is a good piece of kind of starting information. And a lot of parabolas can be figured out by starting here and noticing the transformations. Right? So this parabola is going to look the same as this one, but the +5 is going to move it up 5 units. So this is going to look like this. When you're sketching this on my math lab, you will always start by picking the vertex. The vertex here is 0, 5, so you'll pick that point. And then it'll ask you for a second point on the parabola. That's where this point plays in. This point is 1 unit over and 1 unit up from the vertex. So from this vertex, I go over 1 and up 1, and that gives me a second point on the parabola, which allows me to create that curve. That second point gives it the right shape, so it's not too narrow and not too wide. The axis of symmetry goes right through the middle, and that would be x equals 0 in this case, right? 0 is my x value of the vertex. So the axis of symmetry is x equals 0, that line. Questions about that? Any questions on that? Or
So
any
the
other?
second,
Yeah, go ahead.
the second point is 1 because the x squared, or
Yes, so excellent question. If I put in 1 for x, I
Mhm.
square it, I get 1.
1. Okay.
So that's where this comes from.
Okay.
And then this is what's called a rigid transformation, which means it doesn't change the shape at all. The parabola is like a rigid thing that just gets moved up. So when I move it up, this relationship is still the same, over 1 and up 1. It's a little bit like slope of a line, except it doesn't continue. If you go over 1 and up 1 again, you end up at a different spot than the parabola is. So you can't just sort of go up like a line, but it does allow you to find this one other point very easily. There's lots of other points, and I could put in values like x equals 2 or x equals -3, and I would get a y value there. Often those points aren't as convenient. And as soon as I start plugging values into the function, that means I have to do some calculations, and we can make mistakes that way sometimes. So I think it's useful to do that. It's also going to be helpful once our parabola starts to stretch a little bit. I have some more examples that I can do, but are there any other specific questions from the homework?
I have a question on this one.
Yeah.
So how did you get, like, you said over 1, up 1?
Yeah.
So I wanted to know how you got that.
So that's what I was just saying. This original parabola has this point here,
Mm-hmm.
which is over 1 and up 1 from the vertex. So when I do a rigid transformation, which is just adding 5, this point here has that same relationship to the vertex, over 1 and up 1.
Are we doing over 1, up 1 because of square root of x? X squared, I mean?
Well, it turns out that way, but that's where the first point comes from.
Okay. What
Um,
if, for example, the x squared is like x to the 4th or x to the 3rd?
Well, that's a good question. That changes the way it looks, and it would be a different shape. And that's a topic for college algebra. So you will learn what those look like and those other types of functions. But for our course, we just stick with the x squared. Some of the same principles apply to those other functions, but their shape is different. So an x cubed function looks like this. And
Nice.
x, the fourth function, looks kind of like a parabola, but it's like steeper and kind of wider at the bottom. So those are functions, but they're not ones that we're expected to work with.
So what if it was like 2x squared?
So that is a quadratic, and that is one that we want to work with, and that also is a little different than what we have here. So let's take a look at that one. What happens is this number in front that's multiplied by the x squared, we call that the a value, and that comes from this, right? This is ax squared plus bx plus c, so that a value is what's in front of the x squared. And what that does is that's going to change the width. So this is a non-rigid transformation, which means it doesn't, the shape is now malleable. It's going to flex and change, right? When you multiply by 2, what that does is it stretches the parabola vertically. It really doubles all of the normal y values. So normally you'd put in 1 to the sort of basic parabola. You'd put in x equals 1 and you would get out 1. But you can see for this parabola, you put in 1, you would actually get out 2. It doubles what you would normally have. And so we can sketch this one as well. It's still centered at 0, 0 because I haven't added or subtracted anything. That's how I move the parabola around. But the 2 stretches it out. So instead of going over 1 and up 1, for this stretched parabola, I'm going to go over 1 and up 2. Sometimes a little hard to see when I'm just sketching it by hand, but this parabola is steeper than the standard parabola. That's what that 2 in front does for us.
And if it were 3, you would go over 1 up 3.
That's exactly right. And also, if it was -3, I'd go over 1 and down 3.
Right.
And I would get a parabola that was quite narrow and stretched out. I kind of missed the point, right? But going down.
Okay.
So this, what we want to see is kind of what like the different parts of the function do to the graph. So this a value, we can see what it does to the graph. It determines whether the graph opens up or if it opens down, and it determines how wide or narrow the graph is. So it kind of does a lot to the graph. F of x equals 2 x minus 1 squared minus 3. So ignore that. So this form here is called vertex form, but we can see it as a transformation of our original x squared. It's really had 3 things done to it. Do you guys remember what the -1 does on the inside? When I transform or use transformations?
It becomes positive.
So it changes the original graph. It moves the original graph around. Do you remember which direction it moves it?
To the right.
That's right. So that is kind of the positive. I think that's what you were thinking, right? It does move it in the positive direction, and that's to the right. The -3 also moves it. How does that one move it?
Upward.
So it moves up and down, but because it's a minus, it moves it down.
Okay.
So you're going to take your original vertex, which was at 0, 0, and you're going to move to the right one, and you're going to move down 3 units. So my new vertex is at 1, minus 3. So notice I can really read that vertex off directly from this equation. I like to think of it like y equals mx plus b, right? That's a line, and you can just read the slope right off of that equation. It's the same idea here. I can read the vertex right off of that. It's the opposite of this number for the x and that number for the y. The vertex is really important, but I also need to know how it's been stretched. And this is that a value. So because that's 2, from the vertex, I can go over 1 and up 2. I could do it on the other side as well, over 1 and up 2, because it's symmetric. But when you're doing it on my math lab, you just need 1 point. And there we have a sketch of our parabola. Let me write that out kind of more formally for you. HK is the vertex, and A determines the width and whether it goes up or down. So notice we take the opposite of whatever this is and just that to get my vertex. The first thing is just to make sure when you see this, you know that's a quadratic, so I know the graph is a parabola. That's number one. I've got this as a parabola. Now the question is, what parabola? And that's where recognizing the vertex and the A value. So the vertex here, remember, I take the opposite of this for my X, and this is my Y. You can also do it by the transformations, right, that we thought about. The minus, this +2 means I move to the left 2 units and up 1 unit, and that's going to take the point that was at 0, 0 and move it to -2, 1. The A value here is just -1. And from that information, we can come up with a real good graph of what this looks like. -2, 1 with my vertex. The -1 means it opens down. So I can just go over 1 and down 1. You don't have to use these points. You could put in another X value and do the calculation and find whatever that point might be. That would also work to sketch it. But the over 1 and up 1 is pretty handy, so it's worth figuring out. Questions about this? Okay, I'm hoping that's a good thing. This is basically kind of like half of the, well, it would be I think homework 4. Homework 5 is the same thing, but rather than working with vertex form, we're going to work with what's called standard form. And again, different books do call these different things sometimes. One of the college algebra books calls them kind of standard form, and I can't remember what the other one is. They mix them up. So don't get too locked in on those names. The standard form would look like this: 2x squared plus 8x minus, let's see, plus 5. So the problem here is, well, the one good thing is that this is still my A. So I know that this parabola opens up and it's been stretched by 2. Okay, this is doing the same thing that the A was doing in my other problems. But the thing I don't know right now is what's the vertex? It's not in this form. Kind of a bummer, I'd say. You can take it and rewrite it in that form, but it's not easy. It's actually pretty hard. It can be hard to do. It's a completing the square kind of problem, which we did a little bit of early on in this section, but it's kind of modified and doesn't work very easily all the time. So we really need a different method to find the vertex when it's in standard form. And it turns out if you did go through the process of completing the square, the x coordinate of the vertex would equal minus b over 2a. That's a formula you would definitely like to remember. It's kind of like the first half of the quadratic formula, actually, if you some reason forgot about it or lost your note sheet in a snowstorm or something on the way to the final. It's the negative b over 2a, just not the square root part. And there's some reasons for that. They are sort of connected, but it's telling us something kind of different, which is the x coordinate of the vertex. So in this case, what I would do is I would take negative b over 2a. Negative 8 over 4 is negative 2. That's not the vertex. That's just half of the vertex, right? That's the x coordinate of the vertex. For the y coordinate, I plug that in. You put whatever you find just right into the function. 2 times minus 2 squared, 8 times minus 2 plus 5. 8 minus 16 plus 5 equals minus 3. Now I have the vertex. And I have the a value. -2, -3, with an a value of +2, go over 1 up 2. So while it is a little different process, it's the same general idea in that we want the vertex and we want the A value. And once we know those things, we should know what the graph looks like. The only difference here is that it is a little bit more work to actually find the vertex. We prefer, or I certainly prefer, this vertex form, but we don't always end up with that. So we need to be able to work with both forms. Here, we don't really need any formulas. We can sort of figure out what the vertex is. I mean, you can figure it out if you know how transformations work, right? And then for this one here, standard form, we do need this little formula to kind of get us started on that vertex. Questions?
I have a question on this one.
Great.
So if the vertex is -2 and -3, do you go over 1 and up 2?
I do, because of this.
Okay.
So the vertex is -2, -3. If I don't know anything else, that parabola could open up, it could open down, it could be wide or narrow. I don't know. That part is determined by the A.
Okay, if it's negative, you go down.
Exactly. If it's positive, you go up. And if it's 2 or 3, then you have to stretch it out, right, by 2 or 3. And if it's just a 1, there's nothing there other than a 1, then you just go over 1 and up 1. I think these are good problems for us because they are they're not super complex in terms of you don't have to do a whole lot of calculations. Like the quadratic formula is certainly way more calculations, right, than any of these types of problems, but you do have to see and think about the different components and how they all fit together, right? Combine that. And in order to be successful with that, you have to have a little kind of framework of like, what should you be finding? And so that's where understanding that every quadratic is a parabola is an important step. So, sometimes after we do this section, I might give someone a question like this. And a lot of times people will start sketching a parabola here, but that's wrong, right? This one, while it looks kind of similar, is not a parabola because it's not squared. This is just minus 3x minus 6 minus 1, which is minus 3x minus 7. And that's a line. This is a different relationship. We know the y-intercept of that line is minus 7. And we know the slope of that line is minus 3. So go down 3 over 1. So it's a similar process, right? In that the equation is telling us information about its solutions. Each different type of equation has a different pattern for how the solutions fall. And our goal here is to become comfortable with kind of two main patterns, which are lines, this example here, and quadratics, which are the ones that we've been working on. As the question was asked in the beginning of class, well, what about x cubed and x to the 4th? Well, those are also equations that have patterns, and we want to know those, but we have to wait a little bit, right? So all of these different kinds of equations and relationships have patterns, by kind of understanding the patterns and what's important about them, that helps us understand the relationship, right? And really the relationship is the thing we care about. How are these two quantities connected? Because as I've said before, in math, we just use X and Y, but really the X and the Y stand for something, right? So when you run into these kinds of questions, you know, the X might be your sales and the Y might be your profit of your little company, right? Or some sort of chemical reaction that's happening in your medical lab, or you know, all kinds of different things. Those are relationships between those two things. And so you want to make sure that you understand what that relationship is doing, right? And obviously a linear relationship is very different than a quadratic relationship, right? Quadratic has this down and up or up and down process. Linear is just a straight line. So that's an important distinction for us. Other questions at all? Anything else about quadratics, or, you know, so I mean, this section, there's all about solving quadratics, but there's a number of different techniques, right? There's completing the square root property, of course, the quadratic formula, most important, and a little bit of factoring, right? Those are all strategies for solving quadratics. And then we move into the graphing, right? And the two different styles of graphing, right? Depending on how your equation looks, you can find that information in different ways.
I have a question from my math lab.
Yeah.
So there, I don't remember, but there was this question. I was a little bit confused on how they solved it. You also did one example last week. For example, if we have an equation, like 2x squared plus, like for example, 2x and then plus 8, I'm just putting a random number, but equals 0. When do we add, like, you know, like, I don't know what it was called, but
Okay.
you know how like you move the 8 over the other side?
Yes, I know exactly.
I was a little bit confused on that one.
So, okay, that's a good question, and we can easily, I think, clear that up. I think the process that you're talking about is the completing the square. That is a process that we can use to solve quadratics. It gets replaced by the quadratic formula, because the quadratic formula is really, doesn't feel like it, but it really is completing the square, where that formula comes from. So my choice is to say, I'm going to have you do a tiny bit of completing the square. So I'm going to give you very simple problems that have no extra complications for you to solve by completing the square. And so on the final, I will say in bold, solve this problem by completing the square. So if you have that, this problem actually has some slight complications, so it wouldn't be for this one. But I would give you a quadratic like this and say solve by completing the square. And so this process is where, yes, you add this 5 over to the other side, and then you add something to both sides to complete the square. And it turns out that the thing that works is half of this squared. So half of 8 is 4. And if I square it, I get 16. That works because now when I factor this, I'm going to get an x plus 4 and another x plus 4. I'm going to get a square, a perfect square. And this, when you have a perfect square here, you can solve this by the square root property. X plus 4 must be plus or minus the square root of 21. And x equals minus 4 plus or minus the square root of 21. That's not a process I expect you to use in other situations. You can, and if you do it properly, you'll get the right answer and you'll get full credit. But it's usually more work than the quadratic formula or factoring or kind of our other methods. Okay, so, but it is also a skill that helps us change quadratics around, and actually you might see that this is the way to change kind of a standard form into kind of a vertex form. It is actually a completing the square process. So this type of problem has it shows up again and again as we work through algebra. That's also part of the reason that I want you to know how to do it, even though we have some other methods for solving quadratics. This one over here, it turns out because of this 2 in front, it's not as easy to do with completing the square. Now, we could divide everything by 2 here, which would make it a little easier, but it wouldn't be a good candidate, and it wouldn't be one that I would choose for that problem, just because of those other complications. Nothing wrong with it. We can solve it with quadratic formula.
I just put random number together because
Yeah,
I didn't
of course.
remember.
Of course, it worked, I think, right? This was your question, I think, right?
Yeah, that's my question. Thank you.
Yeah, so it worked, your random numbers to illustrate what we wanted. Other questions? Okay. I will let you go, but remember this work is due on Friday. So we have 2 days, to kind of finish this up. And then that should give you some time over the weekend and the first part of next week to make sure you're prepared for the final exam. So I'll see you on campus for the final exam on Wednesday. And again, let me know always if there's any questions throughout this next week. Okay, so good luck finishing up the material. Finish strong and make sure you're well prepared for that final exam. All right, and I'm sure again, if you've been working through the homework, participating in these sections, you should be well prepared. It will be in my mind, kind of similar to the midterm exam in terms of the way it looks and general structure. Okay. All right. So have a good rest of the night. And again, let me know of any questions and I will see you on Wednesday. Okay. Thank you.